Alright, what we're going to do is process M33, the Triangulum Galaxy. On here you can see what we're starting with. This is pre-processed, and we've got all the various nights here, and where it did the meridian flip, you see it causes all this dark areas around the image. So the first thing we have to do is use a process called dynamic crop to basically clean this up. This is the first thing you do. So it's processes, all processes, dynamic crop. Just shift that over there so you can see it. And then just draw a box like that. You can run this more than once, so we'll do that initial one there. I need to do a little bit more, just here. Yeah, that looks good. Just I'm just going to move it right slightly just to exclude that star. We don't really like having stars right on the edge like that. And just click the tick box just here to run the dynamic crop. And with that done, we shut down dynamic crop. So here's the image, nicely cropped. Next thing we need to do is sort out, there's a little bit of gradient in this image. So we need to sort that out next, which we'll use dynamic background extraction for, which I have an icon saved on my screen here. And this is how I run the DBE. I don't cover the screen with lots and lots of squares. I just use this around the outside. But I do move the squares around so they're off bright stars. So you just got to move them away like this, each one. I find it helps a lot to balance things out if you do this. We've got one there, look. That's about right. Then we just click the tick button here. Actually, before we do that, just show you the settings. The subtraction, discard background model and replace target image. And the sample generation is 51 radius, 0.750 minimum sample weight, and tolerance of 1.1. These are numbers that seem to work for me. Anyway, we'll click the tick button and let it run. It's quite quick, so we'll be done in a second. And shut down DBE. Unstretch it and restretch. There we go, you can see it's cleaned that up quite nicely. Okay, so the third process that we do in this post-processing, I mean, you can see this is PixInsight, and it's, a lot of people say it's really complicated, but hopefully from what I'm doing here you can see it really isn't that difficult. But the next process that we do, I guess it is difficult if you want to dive into each one of these different processes and tweak things around to try and get things marginally better or a lot better than they could be. But I just go with the default settings. It seems to work for me. So the next process that I'm going to use is Photometric color calibration. What this does is it calibrates the image, but the first thing it has to do before it can do it is it needs to solve this image, which is nice because it then builds coordinates into the image which can be used later. So we click on the search coordinates button here, and we'll just type M33. Click on get. You can see now these boxes here have been filled with the right information. Focal length it's given me of 1000 and pixel size is 9. Well, it's not. I'm just going to put 1 there, and I'll drop that down to 500. Sometimes you have to fiddle about with this to get the right numbers to actually get this this to work. Leave everything else as default and just hit the square box just there. And this will now solve this image and color calibrate it. I'm just going to leave the video running just to make sure it's done. You can see when you see this data like this on the screen, then that tells you that the process has worked. It's solved the image, and now it will go on and calibrate. So I will return when this is finished calibrating because it's not that quick a job. Okay, so that's the photometric color calibration done. So we'll just close that down. You can see it's starting to get better. This is literally 2 minutes into processing. However, I do think that to make it as easy as this, you have to get good data first. And this image was constructed from 71 subframes at 5 minutes each. And I went through, I actually had, I think I had about 100, but I went through them and I pulled out all the stuff I didn't like first. So hopefully we've got reasonable data here to use. And there is a little bit of a bonus coming at the end of the video as well, something we saw while pre-processing. Anyway, the next process that we use is denoising. Now for denoising, what I use is a script called Easy Denoise. In fact, I'm going to read his instructions there, and I'm going to save before I do this, because sometimes it does kill your PixInsight, and then you lose everything you've done. You've got to start again. So I'm just going to save this. I'm doing this as a project within PixInsight. So I'm just going to save this project. Shouldn't take too long to save this because there's not a lot here to save just yet. It's just saving the processes in the image. Having said that, it's taking a while. Oh, here we go. So it's writing the image now, M33, to the hard disk. I'll be back in a sec. Okay, so that's done the saving of the project. Now we'll run this script here called Easy Denoise, which was written by a guy called, well, his nickname's Dark Archon, but it's SD Munt and M Shu. Not sure how to say that. And this basically, it makes it very easy to do your denoise on your image. And all we do here is select M33 like this, and I just click the button Run Easy Denoise. You can go through all these and create the masks and check it out here and everything and see what's going on, but I found just clicking Run Easy Denoise works fine. So I'll click that. This is not a short process, so I shall come back when this is done. As you can see, just before I pause this, it's creating all the masks automatically to use with the image. So I'll return when this is finished processing. It takes quite a while. Okay, so we've done the noise reduction on the image. Now the last job that we do when it's in linear mode on this particular image will be to give it a stretch. So it comes out of linear, it becomes non-linear. And to do the stretch, what we'll do is use histogram transformation. There's 2 or 3 ways of doing this, but I'm going to choose this one in this case. So reset all these back. Remove the temporary stretch just here. And then what we do is turn on, what we do now is turn on the real-time preview. Hit that check mark. And first thing is to move this slider here, the center slider. Move it to the left, so you start seeing the image come through out of the blackness. Keep moving it like this. Now what I'm doing here is I'm rolling my mouse wheel towards me, and what we'll do is we'll move this left hand slider to the right, being careful not to clip any blacks. You'll know when you've clipped blacks because this number here will show you how many pixels you're clipping. So we need to keep that at 0 if possible. I normally put it about there just to give it a bit of room. And keep moving this middle one left. Now what we're trying to do here is find a balance between the blacks and the whites. If we go too far, you'll see it brightens it up, gets it over the top. And this here, this position here is obviously too less because you're losing detail. I'm trying to get balance between the blacks and the whites on the image. So I like that spot just there. And click the square button. Real-time preview turns all white. Reset histogram transformation. Shut down the preview. Shut down histogram transformation, and there's the stretched image. It's now no longer linear and it is non-linear. So now we're in non-linear mode. What we have to do is create some masks. Masks are important because when you're working on one part of the image, you don't want the other part to be affected. We've done some background work on this image, so when we start playing around with colours and brightness and whatever else, we don't want to affect the background. So we need to create some masks that protect the main object, the stars and the background. So the first mask I'll create here is going to be the star mask, and we do that by going to StarNet process here. Make sure you've got create star mask ticked, and then hit this button here to create a black and white image or a grayscale image, and then run the StarNet process on that image. It takes quite a while, so I'll come back when it's done. So there's the star mask created. What I'll do is I'll just close down StarNet. We're done with that for now. Right click this image on identifier. I'm going to change the identifier name to just SM for star mask, and drop that up there. And this image here, you can see this is the image with all the stars pulled off it. We don't actually need that, so we can close that image. So the next mask we're going to make is a mask to protect the galaxy. So we go for this one, we'll again create a black and white image by clicking that button there. And then we'll go to Histogram Transformation, click the tick button, make sure it says M33_L, that's just the luminance here, or the grayscale. Reset your settings on here, that button there and that button there, and open real-time preview. Now in this case what we want to do is make it a bit more crushed like this. So we're going to drag this up here like this, and play about with this so you get a reasonable mask to protect the image, or to protect the galaxy. Just playing around here. I think that'll probably do it, and then click the square button, and that will apply this stretch to our black and white image, thus creating a mask. And close down real-time preview, close down histogram transformation, then right click on here, go to identifier, and I'm just going to put the identifier as M and put that up the top. So now we've got two masks created. And the third mask we're going to create is created using pixel math out of these two masks. So we'll go to process, all processes, pixel math. And what I want to do is I want to subtract the star mask from the mask we just made that protects the galaxy, because I'll show you why. If I use this mask here that we created and drag that over the image, you can see that yes, the background is protected, but the stars are not, and neither is the galaxy. So if we work on the galaxy, whatever we do to the galaxy will also affect the stars, and stars can be very easily blown out and distorted. So we want to figure out a way to try and protect the stars as well while we're working on the galaxy. So just remove that mask. And this is the M, so logically if we type in an expression here in pixel math, type M minus SM, remember SM is our star mask, create a new image like that, hit the square box. Now you have a third mask, and if we now drag that onto the image, you can see the galaxy is not red, but the background is, and so are all the stars. And this is so, in theory, what will happen is when we work on the galaxy, the background and the stars will not be affected by whatever we do. And I'm just going to maybe change this and make it M2, mask number 2. Drop that up there. And remove the mask. Shut down Pixel Math. So let's have a look at what we can do with this image now we've got our masks. So we'll put on the star mask first, like that. Just let's have a look, see what we're actually protecting. Show mask. You can see here everything is red apart from the stars, which are white. So what we can do here is just boost up the colours of the stars a little bit. We just drop off the mask, or unshow the mask, sorry. Go into curves, hit the real-time preview button, hit the tick box, and click the S button here. Just grab hold there, just lift that curve. And you can see now some colour is starting to appear back into our stars. It's before, after. So we'll apply that to the image. Now you can see the effect of a second stretch. If we applied this is what the star colours would be like. It's getting a bit too much for my liking at the moment, so I'm just going to drop that back down there. Just add a small bit in just there like that, and then hit it again like that. Hit the square button again. Shut down real-time preview, shut down curves transformation, and remove the mask. The next thing I want to try before we start putting colour into the galaxy is to try and make it a little bit more defined. You can see here that it's a bit, well, not smudgy, but a bit not defined. The lanes aren't that well defined, etc. So what we'll do is we'll put on our M2 mask onto the image. Just show the mask just to see what we're looking at. You can see now we're protecting everything apart from the galaxy. Unshow the mask, and we'll use a process called HDR Multiscale Transform, and I'm going to show you the effects this can have on the image. Now the default setting is 6, so if we put it down to 5 and we'll apply that to the image, just see what it does to the image. Just have to wait a few seconds for it to apply itself. Now you can see what it's done if we use 5. So obviously I don't like that. Some people might, but I don't. So undo that. And I'm going to put this up to 8. I previously looked at this. Let's look at 9 layers. Drag that over there and see how that looks. Okay, so that's on 9 layers. Let's try it now on 8 and show you what it looks like with 8 layers. You can see, look, if I go backwards and forwards, you can see it makes the lanes a little bit more defined out of just this general whiteness or pinkness, whatever colour that is. So we'll just undo that and we'll drop this down to 8 layers and apply that. Right, let's just zoom in here. Right, okay, that's looking a bit better now. So we're going to keep that for this image. 8 layers on HDR Multiscale Transform. And then with that done, we shut down HDR Multiscale Transform. So with that done on the HDR, let's try and add a little bit of colour into the galaxy. And we'll start off, we'll just take a look at what we can do with this, because from this point it's a little bit experimental. So we'll load up Histogram Transformation. And we don't want it on that image. First thing we need to do is put a mask on. So we're going to put this mask over the galaxy, so we're not affecting the background. There's your real-time preview. I just wanted to add in just maybe a little bit of blue. Now we can do this. You click the B button here. Obviously if we do this, and it will go get totally out of hand. If we just add just a tiny little bit like that, that's how I like it. Don't want to go too far. And maybe a bit of red. You can see we've got these red objects here. Actually they are part of the galaxy. We just slide that red up a little bit just to give it a bit of a red, and we'll apply that and shut down the real-time preview. There we go. So we've added a tiny little bit of colour into the galaxy. I may add some more, but we'll leave the histogram transformation for now. So the next job we'll do will be just have a play around with the curves tool here. I'll bring up the real-time preview. Just want to have a look at the effect of if I increase the saturation on the image. You can see there it's bringing up the colours that we just boosted a little bit using the histogram transformation. There's after, there's before. Don't know if you can see it on YouTube. It's after. As before. Just drop that down just to there. See these red areas have now started to show up. This image is done with an Lpro filter, not the L enhance, so I haven't filtered any of the HA through here. Obviously if we did it in HA or whatever, then you'd see a lot more redness in here. But this is looking quite good as it is, so we'll just want to drop this down again. Just need to check. Don't want to go too crazy with the colours. Right, that'll do. And we'll apply that to the image. Now this is what would happen to the image if we did that stretch again onto the colour. For me it's too much. You might like it, but for me it's a little bit too much. So let's just drop this down. And we'll apply that second colour stretch on it. And close the preview and close Curves Transformation. And one more little job I want to take a look at. I'm going to take off the mask, and I may not keep this, but I just want to have a look at what happens if we play with the contrast a little bit. So if we drag this all the way down, then it starts to clip everything. It's not good. Too far it goes there. We can lose that down there. Just drag this up a little bit. So we've got a little bit of an S curve on the image, like that. Let's just check before and after. This is after. And here's before. You see it's brought out a bit more contrast in the image. It's made it a bit more contrasty. So we'll apply that. Shut down the real-time preview. Let's have a look, see what we're looking at. It looks quite good. Okay. And after this, I just want to have a play about with the colour saturation tool. Put on the real-time preview. I'm looking at these brownish areas in here. See if we can do something with those. Just reset that. I'm going to put a preview over the real-time preview. And I'm guessing these brown areas here are, yeah, they're right here, right at the end of the spectrum. So I'm just going to just shift that across into the middle there. So we're going to be working on this area here. So let's just put some dots in so we don't shift the colour on the whole of the image. about there, wasn't it? Let's just move that up. Let's just check before, after. Hasn't really made much difference, so we won't bother with that. We'll leave that off for now. And the last thing that I'd like to do, actually maybe one or two things, but these are going to be tests. Maybe sharpen the image a little bit more. Now I have a process here, Multiscale Linear Transform, which with these settings will sharpen an image. So let's grab a preview on that and take a look at the real-time preview and see what this does before and after. You've got to be a bit careful with MLT because it can bring in ringing, and you can see there it's just a bit too, what I would call crunchy. It's not subtle at all. Some people may like it. I don't particularly like that. So shut that down. The other process that we can use is unsharp mask. If we bring up a real-time preview. Now that's better. That's really subtle. I don't know if you can see that across the YouTube on the video here, but it's a really subtle change. It's not brutal like the MLT was. So we're going to apply that. Obviously you can apply these processes more than once. But I'm going to leave it like that on the preview. Now I don't know if you can see the difference if I apply and reapply it on the preview, but that looks pretty good to me. So now we'll remove the preview and apply unsharp mask to the whole image, or the whole masked image. There we go. And the last little process I want to look at is removing the stars, which we may or may want to do or not want to do, but we'll give it a try, see what it looks like. So we go into here, easy star reduction. In fact, before I do that, I'm going to save the image as per his instructions. So I'll save the project. We'll just pause this while it saves. And we'll run this process. It's got to pull off the mask first. So remove the mask. Go to script, easy processing, and easy star reduction. And let's see what this does to it. So we choose the view, which is M33, and run easy star reduction. Actually, let's just had another thought. Let's just do this. We'll run off a clone so we can do we can check before and after. So easy star reduction. Choose our view, which is the M33 clone. Run easy star reduction. This will take a little while, so I'll come back when it's complete. Okay, so there's the image with the stars reduced using that script. Let's take a look at comparison here. Do we like it? Not sure. I'll keep both of the images though. I tend to like images that are more true to what's actually up there rather than trying to make a picture with no stars or greatly minimized stars. Because the stars are there for a reason, eh? They're part of the sky. You take a photograph and then process the hell out of it so there's no stars, and it's kind of, I don't know, just odd. But I'm going to say both. I kind of like both. Just make it bigger. There's M33. So the last thing we're going to do is just save these as JPEGs for the website. And then once I've done that, we'll move on to the discovery. Well, not discovery, something that two of us discovered in our images, which I'll show you once I've saved these images. So save that clone as save it as an XISF, so it keeps all the history embedded in it. And we'll save as a JPEG for the website, which PixInsight doesn't appreciate and will complain. And the same for this one. Save as. Actually, I've been working on fits in this. Doesn't really matter. I'm just going to call it M33.xisf. And save as M33.jpeg. And again, we'll get PixInsight complaining that we're using JPEGs to save images, but for a website, well, we've got to do it. Okay, and you might have seen there that I was actually saving as projects. Now, the beauty of using a project is that you can keep all of your processes here, what you've actually done. So if you look at M33, you can see the last process I did on M33 was the unsharp mask. But if we go over to M33 clone, you can see there, look, that's where I did the morphological transformation, which was part of the star reduction. So it's really useful to do things as a project in PixInsight because you can keep all your history here. And if you want to go back, if you think to yourself, for example, maybe something's not right here, which it possibly isn't for some people's eyes, I think it's okay, you can go back to one of these previous processes, and just by double clicking here, you'll go back to that point in the actual image. So if I was to actually double click there, it will drag it back to before it was even stretched, when we did the photometric color calibration. And back there brings our image back. So that's why I use a project. So that's it for the processing of this image. Now I'm going to show you that something that two of us actually spotted in our subs when we were processing the image, which was an asteroid. So give us a minute, I'll load up all the stuff for that, and I'll show you what we saw. So what basically happened was, on the Nina Discord, one of the guys there, Calzu, then popped a message into chat saying he'd found a moving object and could anybody identify it. He's the one that first saw it, not me. And I looked at it and went, well, it looks like an asteroid. What object were you imaging? And he said M33, and this was the same night that I was imaging it. So I thought, well, I'll have a look, see what's going on. And you can see on the screen here all my subs. Now these subs have actually been registered together so the stars don't move around, which is how you do if you're looking for asteroids. Basically what you do is you take all your subs, you register them, save those images, and then you look at those. You don't continue the processing. So what we're doing is looking at the image using Blink, which is a PixInsight process. And if I click the play button with a 0.05 second delay on it, it'll blink through all my images very fast. Now I can see the particular object because I know exactly where I'm looking. You probably can't on YouTube, but if I zoom in, you'll see it. Let me just stop that. It's right about here. This is M33. This is what the subs look like before we process them. So if we zoom into this area here, I think it was around here. Let's just make that a little bit bigger. And we play again. Can you see him moving across there? And this is how you find stuff that's possibly on your subframes that you don't think about looking for because you're just there to process the image. And that moving across the screen there, hopefully you can see it, is actually an asteroid. So which asteroid is it? Well, it turns out that it's asteroid 42685 1998 JY, whatever that annotation means. So having that information, we can now look up some more information on it and see what else we can find out. So what I did first was I stuck one of the images into Astrometry and solved. I actually sent the image to them with the asteroid as close to the centre as I could to get the RA and deck. So we've got 1 hour 35 RA, 30 minutes 45 on the deck. Now if you go to a website here called the Minor Planet Center, you'll see the information about this object. Loads of information here. Obviously it's not a new discovery, it's not a new thing because it was discovered in 1998. So it's been around a while, flying around up there. And here's the RA and deck numbers. If we come down to roughly where I found it, so there's the RA and deck look. So it's very similar to what we had. Hold on. So 134, 3018, 135, 3045. So it's pretty much got it there. So that confirms that this is the actual asteroid we were looking at. And what we can also do is load that number 42685 into Stellarium. Now I'm doing this in the daytime, so obviously Stellarium's looking sort of at the ground, but it also gives you the numbers. And the interesting number is our distance, 124 million kilometers from us, and the velocity, which is 24.987 kilometers per second. So that's about 25, so say 25 kilometers a second. So if the speed is around 25 kilometers per second, and those images that I showed, that I blinked through, was approximately 4 hours of imaging, you can calculate, if my maths is right, and somebody will correct me if this is wrong, that over the course of those 4 hours, that asteroid moved around about 36,000 kilometers in that 4 hours, which is really cool to figure out. That's what we can figure out from just looking at those blink subs, you know, what it is, how fast it's going, just by using tools that we've got like Stellarium and the Minor Planet Center. So that's what I wanted to show you on the asteroid, which I thought is pretty cool. So to finish, what I'd suggest you do is when you're doing your imaging of, you know, whatever object you're trying to get a picture of, also do this, also blink your subs. Register them, then blink them. Have a look at them carefully, because that moving object, it took me a little while to find it on my screen. And see what you can see. Then you know you've got something else to do with the data you've collected, rather than just process it into the final object. So with that, thanks for watching, and clear skies.